Anyone who's spent time as an engineer knows the importance of tests. Developing comprehensive tests for complex software systems can be difficult, and a test suite doesn't always imply guarantees on all aspects of even a single program's behavior. Going beyond the testing you or I could come up with, formal verification involves proving the absence of costly or dangerous bugs in software systems. While this might sound like overdoing it to some of you, there is a lot of value in being able to prove a software system works as intended. This is especially true in systems that interact with critical infrastructure or whose failure could lead to devastating consequences. As it turns out, there are some important ways this work interacts with machine learning. To give an example, researchers are looking at how large language models can help repair incorrect proofs. On the other hand, you might care that a system involving deep learning behaves correctly and want to make certain guarantees. My guest today is Professor Talia Ringer, whose work aims to build a world where programmers of all skill levels, across all domains, can formally verify software systems. One of these domains, of course, is machine learning. Our conversation introduces Professor Ringer's work and discusses a number of topics at the intersection of proof engineering and machine learning. As you might hope, we also spend some time discussing Professor Ringer's feelings about contemporary debates and questions motivated by GPT-4 and its ilk. This is the Gradient Podcast, and I am your host, Daniel Bashir. If you have comments, questions, guest suggestions, feel free to leave me a comment on Substack or shoot an email to editor@thegradient.pub. But now, without further ado, Talia Ringer. Professor Ringer, your research statement kind of describes your goal as allowing programmers of all skill levels to build formally verified software systems. And there are a few different parts in that I think are worth breaking down. But to start with, could you articulate how that became your research goal in the first place?
Oh, interesting. So I think back to a little bit after undergrad, when so before I started grad school, I was an engineer at Amazon for a few years. Um, and I think I would see I think the code at Amazon is like really high quality, but I would still see just like so many things that were really hard and like a lot of bugs that would show up. All software is buggy. Um, and so I think this is kind of part of what drove me towards like the, research area I was in to begin with, when I eventually went to grad school. When I was in grad school at the beginning, I started using, in one of the classes that I took, there was a tool that we could use to actually, prove that our programs are correct, which is really cool and really wild because it feels like almost like science fiction that you could just prove that your program behaves a certain way in all cases ever. Um, and it was like, um, it works. It really does work. I think the thing that I noticed was it's just really hard, and and a lot of people from that concluded like, oh, this will never take off. Whereas for me, it was kind of like, okay, this is really hard, but it doesn't feel like it's hard for like fundamental reasons. So just like, how could I make this easier so that I'd like it to take off pretty much as like unit testing does right now.
Let's perhaps, before we dive into a few different parts of this research statement, focus on one thing. And I think that the idea of formally verifying software systems, of proving they're correct, for somebody like me, the value of that seems pretty obvious. But I'd love for you to make the case to somebody who perhaps is not like me and maybe a little bit skeptical of why should formal verification matter? Why is this something I should care about?
Yeah, that's fair. And I will say, for a lot of people who are into formal verification, will make sort of an extreme case that we should formally verify all software, like always. And I think really I want this to be like one tool that everyone has access to, like writing unit tests. And I would like it to be no harder than writing unit tests. So I do think there are kinds of software where you wouldn't care as much. Like I think about just like I used actually, I think ChatGPT, or no, not ChatGPT, actually earlier than this. Like when I first got Codex access, I was using that with my mom to like make a little game in the web browser, and like we clearly did not care that much about how correct that was. But there's a lot of software where there can be really catastrophic like errors that can really harm like people. Security bugs that show up in software that can leak critical information about people, or even things that can lead to like we're integrating software into more and more things, so you can see like critical infrastructure failures can result from software bugs. I think the stronger guarantees we can get, the better, especially as like the more of the software is being integrated into like real systems that we're using that are actually interacting with people in the real world and that could actually like hurt people.
Yeah, and to flag some stuff we'll talk about in more detail later, I think that's especially of concern for the ML world right now, especially as people are thinking about all the various things that are coming out of Chat GPT plugins and AutoGPT, and just asking these agents that seem to do things pretty well, but in a lot of ways, we can't predict how they will behave in many circumstances at the same time. And just expanding those use cases seems, for a lot of people, really cool, but then at the same time, for a lot of people, just really, really concerning.
Yeah. Yeah, I think it is scary, especially because we don't know like like the ways that they fail might not be the same ways that people might fail at similar things. And so we might just be completely unprepared for that. And then there's also problems with like accountability. Um, when a human like hurts someone else, there are usually systems for accountability. They're imperfect, but they exist. But when you have, a tool that is suggesting code to you, and the code introduces a bug, and that bug is in your self-driving car, and then the self-driving car hurts someone, like who is responsible? um,
That's even more complicated. Yeah. I want to ask about one specific part of your research statement, and I think this extends in a few different ways here. So, a really important part of it is the accessibility component, allowing programmers of all skill levels, not just those who might be familiar with certain proof tools, to build these formally verified systems. And I think part of that is really allowing the programmer to have some level of trust and direct knowledge that their program behaves correctly. And I think this ties into some of the accountability and public use aspects of this as well. But I'm curious about first, perhaps, the difficulties in trying to make this something accessible for as many people as possible.
yeah, that's a good question. Um, I think the primary difficulty right now is that this a lot of these tools kind of work from this space where you already know what your program should be doing, and you can state it, and you can state it pretty formally. And I think in practice, most people like that I've seen when we go to write software, we have like some vague idea of what we want to do, but part of the programming process is actually figuring that out to begin with. Um, and then like some things you can't fully state formally. So it might be a matter of finding really important things that we can state. um, and then there's also this problem of like having to state this very formally as opposed to just kind of having an idea and explaining it of like, what it would mean for this program to behave as expected. And I think, I don't think this is something that we should expect everyone to do perfectly. So I think, yeah. So, I mean, in summary, it's like specification, I think, is probably one of the bigger ones. I think it's also one that I'm really optimistic about because we have a lot of like upcoming work for ways of like helping people interactively with the help of tools, like, specify things, get kind of immediate benefits from this, and then hopefully ease into, being able to use some of these proof tools. But the interface right now also, like, I mean, the interface and the assumption that you just already have a specification, it like very much it works for experts and I don't think it works for others.
I can see that. In my own limited experience, I think a friend and I decided it would be fun to like go through a course and play around with one of the proof tools, I think Coq, for a summer. And it was cool, but it also felt very non-intuitive. And I did find myself, I think you've described this in some of your research, where students will just kind of like try to hack their way through a proof without really thinking through the steps beforehand. And I absolutely found myself doing that because I was like, I don't know what kinds of transformations of things that this system supports. And then at the same time, just like trying to kind of get to the end without really thinking through like the logic in advance.
Yeah, and I guess I feel like that interface, the way that these work is like you have these kind of tactics, which like you'll have a goal, which is to prove like, for every input ever, like my program behaves a certain way. And then you have these tactics that are kind of helping you progress towards your goal. And I think that this interface is reasonable for experts. It's still even a little bit of a lie. Like there's this summary, like people are told that like these tactics are kind of you don't have to know what's going on inside the tool. You can just use these tactics and look at your goals. But if you actually watch experts, um, a lot of the time, like people are extremely aware of what these tactics are actually doing and how they're behaving, so that when they go wrong, uh, they can fix like what they're actually trying. So there's a little bit of a lie there, even for experts. But then I think for non-experts, this is just like emphatically like the wrong interface. I suspect. I think I do think having some interaction is useful because if you throw something to a fully automated tool and it doesn't work, like what do you do? But I want like I think I'd like to see kind of a like mostly automated proof, where then like when it gets stuck, it can just prompt you for like the right information. Um, like ask the user, oh, I almost have a proof of this thing, but like what happens in this case? You know, um, and and that sort of thing. I think that's what I hope for in the long run if we want to make it accessible to people.
That I think provides us a little bit of a segue into perhaps stating a little bit more clearly how a lot of this work overlaps with interests in the AI community. We've kind of gestured at this in a few ways, but first, could you tell me a bit about how your interests started to interact and overlap with ML?
Yeah, that's a good question. So it's kind of interesting because I was wrapping up my PhD in like 2021, and going on the job market for academic jobs. Um, and when you're doing a PhD, you're like very much in this like narrow world where the only thing that matters is the problem you're working on for a while. So I had been there and I had not been paying any attention at all to how the machine learning world was progressing, which was a weird time. And it was a weird time to kind of wake up from that because I had all these interviews where I had to talk to machine learning people, and I was like, oh, I should read these papers. And when I started to read the papers, um, to help me with my interview, I got actually pretty excited because there were a lot of problems. So there are a lot of places where traditional kind of techniques from my field, from programming languages, are really, really useful. But there are a lot of problems where, like, to make these tools more accessible, programming languages techniques, I think, are just kind of hopeless. um, And to me, it felt like the machine learning techniques and the problems that they excelled at like perfectly complemented these. Um, and I could see how these things could come together and really help people. So I actually, over the course of my interviews, I would like propose an idea to like some of these machine learning people. Be like, "Do you think this could help with this thing?" And then we'd like refine it. And then in another interview, I'd present the refined idea. And yeah, by the end of this, I actually had a collaboration with like one of my later interviews with some folks at UMass, like Emily First and Yuri Brun, um, and so on. And like that, yeah, that just came out of this kind of refining these things.
That's a fun way to come up with a research agenda. Let's talk about how that's manifested. And you've presented this in a couple of ways. You articulate it really well on your website. You also gave this talk called Concrete Problems in Proof Automation, where you looked at more of the side of this, as you just discussed, where ML can complement what perhaps proof engineers are trying to do. So maybe we can start with that. How can ML help people who are trying to verify software systems?
Yeah, I mean, there are a lot of ways, I think. So one thing I found it really good for is like, so if you look at these tactics that people are writing, um, they're really like a kind of old-fashioned AI, like symbolic automation that's doing some kind of manipulation of these proofs, to advance. And so people build really nice abstractions into these, and that's cool. But like, they're still pretty kind of low level once you look at an entire proof. And so I think one of the things I'm really excited about with the machine learning side of things is that you can actually reason one level higher about like once you have these abstractions, like how do you use them? Um, and they are much more natural than a low level programming language because people will build in nice abstractions here. But they're still kind of a programming language, but they don't have like a really clear meaning when you just look at these tactics. They're things like, induction and like just different kinds of rewriting. And then sometimes people will build in kind of custom tactics for their domain, call decision procedures for different things. And it's like they can really behave almost arbitrarily as long as they're progressing in the proof. um, so I think I've been really excited about kind of the potential for helping people like use the right tactics in writing their proofs, or for potentially automating most of the proof entirely, but still producing something that's human readable, which is something that programming languages I think is just not like it can do the kind of try to solve the proof mostly, but like it's often going to give you something that's completely incomprehensible because you can't encode like what a pretty proof looks like, I think, in a in like a programming language's way. But it is something that machine learning will pick up on. It's very good at style, and very very good at, I think, producing things that are like easier for people to understand. um, so that's part of it. I think specification is another one. Like I wrote about this, or I was talking about this before. um, I think, and this is a really tricky one because you don't want to get it wrong. And like one of the nice things about proof as a domain for machine learning is that if you already have the thing you're trying to prove, the specification, the theorem, whatever, like you can check it. um, and so there's no risk that like something goes wrong in the formal proof world. But when you look at specification, there is this risk. Like you're asking the tool to think of the theorem. It's a little scary, but it's also, I think, really promising if we do it carefully, because I think you can get to this world where people can kind of pass in what information they have. Like I have some tests for my program. I have some, I can explain in English like how my program is supposed to behave. um, I can give you all this information. Now, can you, formally state what it should do for me? But then I think we have to be careful when it spits back something formal to make sure that people can actually understand it, interact with it, and won't just kind of naively believe that that specification is the one they're looking for. So it's a little complicated.
That's really interesting. I do recall in some cases taking this even a little bit further, maybe how people have taken chunks of code and fed them to ChatGPT or GPT-4 and just said, "Hey, actually, could you explain this to me in natural language, what this code is doing?" And so if you're looking at some piece of code and perhaps you have some idea how it behaves, but you're even not sure how to articulate it to yourself at an informal level, maybe you have this kind of bootstrap thing where you can get to that stage and then you're like, okay, now I have a bit of an intuitive idea, let's try to go ahead and formalize it. Of course, as you said, there are now like multiple juncture points in the system where you probably want a human there to be careful about like, is this outputting the correct thing? But it is kind of interesting just to imagine how you can kind of step back down the stairs in terms of where you are and allow something to bootstrap you to where you want to be at the formal verification level.
Yeah, that's cool. That does sound really promising. Yeah, because I could think, one thing you could do, okay, let's like you write a program. Yeah, again, you could if you ask it to explain it to you in natural language. Now sometimes your program's going to be wrong, and sometimes it's going to be right. Um, so you know, I think like it's interesting when you get that explanation. Do you want an explanation of how it currently works, or do you want an explanation of how it ought to work? But I think no matter which one you have, you're actually in a good place because if you like say you get an explanation of how it currently works and it's buggy, um, if you ask the tool to like try to formalize that, you can kind of use it to like generate tests as well. And I think this is one of the really cool things about a specification once you have one is like you can use it for proofs, but you can also use it to look for counterexamples. You can use it to generate tests. So that you could generate a bunch of tests and like it could give you an input output example that is just obviously incorrect to you. And if you get that, then you can kind of iterate and be like, oh, this one shouldn't hold. How can we refine how this program behaves? So yeah, I'd love to see like I think this is maybe 10 years out. It's like still hard, but I'd just love to see like this kind of really beautiful interaction loop built into the entire programming process, where you have a mix of machine learning tools that can deal with the fuzzy things, programming languages tools that can do things very formally with strong guarantees, and like all with a really good interface that helps people like reason about the code and improve upon it and get strong guarantees in the end. I think it'd be awesome.
Right now, we've been talking about kind of one direction here. So I have some code that I've written that I understand. Maybe I don't understand it so well. And I'm looking to go in the direction of writing tests, getting formal verification. Since you were a software engineer, you've undoubtedly probably encountered the whole test driven development methodology. And some people are very strict about the idea that I want to write unit tests before I start actually writing or patching code. And so within this discussion, I am curious if perhaps you have any thoughts on the idea of maybe I'm starting actually over here with some formal verification requirements or properties of a program that I'd like it to satisfy. And I actually want to go from there to the program itself if I have maybe some high level specification of what it's doing.
Yeah. So this is interesting. This is a space where I think verification is already very useful. Um, and it tends to be in domains where there are common specifications that you can kind of reuse. Like when people talk about how compilers behave and what it means for your compiler to work correctly, like it shouldn't introduce new behaviors into your program, and it should preserve all the behaviors that you want your program, that you had in the original program. Um, and so this is something that you can state really formally, and people can just reuse this. And there's already like a proof strategy that you can use. And that's really cool. And you see this with a lot of security properties as well, like for operating system security. And yeah, there is some work on kind of like code. Like if you have a specification, you can also use this to synthesize code that meets the specification. And uh, I think this is kind of the ideal world when you're doing any kind of program synthesis, because um, you can, you know when it's correct. um, so there's some work again in like specific domains where like we really tend to know what correctness means. Um, on I think hardware is maybe another one where this comes up a lot, um, where you can even describe at a high level what properties you want your code to have, and it will kind of co-synthesize like code and the guarantees about the program, which is really cool. Yeah, and it is a place where I think machine learning will make things like strictly better, because you just have an extra tool that you can use to help with the synthesis, and you still have a way to check it. um, I just don't think it's realistic for a lot of programs that are kind of novel in some way, um, or that aren't just in this giant class of things where people know exactly how they ought to behave ahead of time. And I do know a lot of times when I'm writing a new program, I don't quite know what I want it to do. And the easiest way to figure out what I want it to do is to start writing the program. Yeah, like so I think there are just different kinds of programs, and we want both approaches to be possible.
One of the ideas you brought up in your concrete problems and proof automation talk was this idea of relation discovery. And perhaps interestingly for our listeners, you mentioned that AlphaGo lost a match because of this kind of issue. Could you describe that a little bit?
Yeah, this is a really interesting one that's informing like a lot of research that I have going forward. Um, but the basic idea, um, so okay, I guess the way that this manifested in like the AlphaGo world was like there was um like the match that AlphaGo lost was there was a game state that was played that was like almost equivalent to, but not the same as, like it was some interesting kind of semantic permutation of some state that it had seen before in training, and it was completely unable to draw that connection and just kind of barfed. uh, and I think this happens a lot also with code and proofs, where you've trained these tools on an internet full of code and proofs about these different data types, like different representations of numbers or lists or trees or whatever, and then you know, a user might be kind of using one of these tools once it's already trained, and they give you something that's just kind of like it turns out to be equivalent to the things that it's seen before, but it's not equivalent in an obvious way. There's not like a straightforward like syntactic relationship between them. There's like you might have to know something to figure out that they're related. But once you figure out they're related, in the code and proof world, you can just kind of like really formally like transfer all your knowledge over from one to the other, which is actually a lot of the my thesis work on the programming languages side of things was really working on like I've discovered how these things are related. I have a proof about the old thing, and I want to produce a proof about the new thing that doesn't talk about that old thing at all. But it's still like the same proof in some sense. Um, and it's really cool that you can reuse this knowledge. But it's like, um, in my thesis work, you would still have people writing kind of like formally writing how these things are related, or very occasionally I'd have like a specialized search procedure that I would write. And I think I'm still the only one who's written one of these for the tool that would like discover these kinds of relations. Um, but I think what's really interesting, from my perspective, is like a lot of times when I look at these um, like data types, for example, um, it would only take me a few examples as a human, like the inputs and outputs of like, or like what I mean, unary and binary, I think, is one that we commonly use as an example, like two different representations of numbers. where unary is like just kind of counting, like zero is just like zero ticks, one is like one, two is two different ticks, kind of, and then just a standard like binary representation of numbers, um, and uh, for me, I only have to see 6 examples um, of like how these correspond to each other, uh, to understand fully how I would be able to write the relation between them, and then how I would be able to take any program or any proof I have about one of them and produce a proof, an equivalent program or proof about the other. Um, and it bothers me a lot that the machine learning tools have no way of doing this right now, both discovering these relations and then kind of formally adapting them, unless there's a really straightforward like syntactic relationship between the things. Um, and yeah, it just seems like an area where if you could do that, you could make everything like so much more powerful. You wouldn't have to rely so much on things looking a lot like the training data. You'd be able to do really novel things, and then maybe with a few examples, it could figure out how to take something that's already been done and show it to you and help you adapt it to this novel context.
There are two different sets of thoughts that brings up for me. Perhaps the first one, because I think the second will probably drive us down a whole separate rabbit hole. But the first is what you just described. I think the deriving or understanding of relations that you and I could do with just a few examples, but large models, I mean, maybe they can do it after a lot more, or perhaps not at all. It does seem to gesture towards some of the kinds of examples that people like Melanie Mitchell, like Francois Chollet have kind of pointed out as these seem like the types of problems where deep learning systems, just as a category, seem to suffer from some of their fundamental limitations. And so that does make me think about perhaps there are AI systems in general that can assist us with this kind of thing. But I do wonder about that question of, okay, is deep learning the right paradigm to look for the relational analogical aspect of things here?
Yeah, that's interesting. Yeah, I don't know for sure yet. I think I've bounced back and forth on this a lot over the last couple of years. Um, I think it's clear to me that like, um, one thing that I've seen these tools suffer on a lot, or that there just really doesn't seem to be a way to express in a lot of these tools, is really like this idea of like rule learning, right? Like, and it's actually really interesting because if you look at like human psychology, I think like babies, like infants at 6 months are able to do some of this rule learning before they learn language. So it's this really cool, beautiful thing where you're able to fully, perfectly generalize when that's a thing that one could do. It's like this generalization to the infinite. um, and that's awesome. And that's what kind of we're discovering from those 6 examples. But I do think, like, I'm not sure to what degree that is fundamental versus just a symptom of like the current tools we're looking at, the current tasks we're looking at. Um, so I'm not positive. I know, like, I don't know. I think when I think about why I can look at just 6 examples and understand the unary binary thing, it's because I have a concept of recursion. um, and like because I understand generally what recursion is, um, and I see these 6 examples, I know like what one would have to do to write a recursive function that's simple and that generates those, and that will, yeah. um and it's like, uh and I don't think there's a way I've seen yet to kind of encode like the concept of recursion um to some of these models. I When it comes to like the actual behavior of recursion, you said maybe some of these tools can do it with a lot of examples. We've been playing around with this kind of, unary binary example in like uh, in a transformer model with no prior knowledge. So like no it's not pre-trained on anything. We're just giving it like these two representations of numbers. um, and it is able to learn the relation. It just takes like I don't know the number of examples, but it's something very absurdly high. Uh, like the only reasonable way to give this number of examples would be to write the function and then generate everything, um, to write the relation already. So um, and it does actually start to represent the kind of like recursion in some interesting way. Now it's with the transformer models, it can't like properly like so-called like do recursion. um, but it's able to kind of approximate it in interesting ways where it's marking like where the recursion should happen. Um, but then yeah, it's just very finicky in like how well it generalizes. It takes a lot of examples. And then I think when you look at, so there are entire architectures that are like theoretically meant for like encoding recursion. And for some reason, they do much worse this task. So, yeah, so I just don't, I think there are just some architectural limitations right now where it's like, um, where I think we could get these things to do better. And I'm not fully convinced that it's like a deep learning flaw. I think it's like we're not giving it an easy way to like generalize to an infinite case right now, um, kind of thing. And like maybe there's a way to do that reasonably.
Yeah, I think you did give a really good articulation about why it's pretty unclear how fundamental that is. One thing you kind of pointed out earlier is you and I have this almost, I guess, prior concept of recursion. And it does seem like humans do have these fundamental kind of concepts, the whole like a priori knowledge kind of thing that a lot of people will invoke. And another way to articulate the paradigm we're in right now, as opposed to just the deep learning paradigm, is well, my architecture has very weak or essentially no priors. And so I'm just training a system at massive scale that has no priors and it picks up whatever it will when it comes to language or other concepts I might want to communicate to it via the training data. But it does seem like, as you're saying, there's a lot of imagination left to be done when it comes to architectural constraints that might provide the right affordances for this kind of thing and maybe mixing things together. There's, of course, the whole neuro-symbolic systems. That seems like a potentially interesting direction that a lot are exploring. But it does seem like we're in a space where we can't really be super categorical right now. Like it's deep learning simpliciter or no deep learning at all.
Yeah, I also think when you talk about like neuro-symbolic stuff, like I really suspect that this is just gonna blur more and more over time to the point where it's like already it's not quite clear to me what makes a system purely neural versus neuro-symbolic. Because like um, you know, if a tool is producing if a a tool that's implemented neurally is producing proofs by way of encoding like its own representation of like symbolic automation over these proofs, these tactics, and then suggesting tactics to people. Like there's a point at which any kind of manipulation of symbolic information feels like neurosymbolic to me. Um, but I think yeah, the degree to which they should be tightly integrated versus like separate things that work nicely together is still pretty open.
Yeah, I guess I also say that phrase being not entirely sure what I mean by it. And I think if we can even be formal about it, there does seem to be like a spectrum of what neurosymbolic means. Maybe like we have some understanding of what is like a quote unquote fully neural system and fully symbolic. And then there's this just like hazy space that is literally everything in between those two.
Yeah. I think this happens with most, like, it's just a bit of a tangent, but like with most machine learning concepts, like I was on this AI for proofs like panel at a workshop at NeurIPS, and someone asked like, to what degree do we think that language models are going to solve the problem of generating proofs? And I think I was just at that point, I was like, what is a language model at this point? Because we used to think about there are just so many things that go into it now. It's like you really don't have um, I don't know if we look at like how people are talking about um like GPT-4, and we don't have access to the architecture, so I don't know, but it sounds like there's like language modeling, there's like a mixture of experts thing going on, there's tool access, there's a large context. I'm like, okay, if you have a bunch of language models interacting with each other in some way, and maybe they have access to memory, and maybe they have access to tools, and and um, and they're able to kind of communicate in some way, then like maybe those could be really awesome at proofs. I wouldn't really doubt that, but it's just not even clear to me what nothing seems to fall into these clear categories anymore, and I think that's good. People are taking well, I think it's good to some degree. People are taking ideas, mixing them. That's awesome. We do need to make sure that we understand the systems we're building to some degree.
Yeah, that's fair. So I do want to dive down the whole robustness verification rabbit hole in a minute, but perhaps first we can put a pin in that for a second because I really do want to discuss your Baldur paper, the whole proof generation and repair with LLMs. I think that's maybe a really interesting way for us to maybe wrap up this component of the ML helping proofs direction. And so could you perhaps just describe a little bit of the motivation for this paper and how you're kind of seeing, LLMs? I think people are already kind of seeing maybe some similarities to what you were doing here when they're like, I'm going to write a program. Hey, help me write this. I compile it. I feed back the error and I kind of iterate and write code that way. So perhaps you could describe a little bit of the motivation and what was going on in this paper.
Yeah, and I think um, just for credit's sake, a lot of the project proposal there was by Marcus at Google. So these are with Google collaborators, and Emily First, the PhD student who's the first author, like really led the work there and was incredible. Actually, she just defended her thesis
Oh, that's
successfully. So
awesome.
congratulations! Yeah.
Congratulations.
um, but yeah, I think there were a couple of really interesting threads there with the Baldur work that I found exciting. One of them is, you know, I think right now there's a question of um, how useful it is to like. There's a lot of work kind of combining these language models with a search procedure of some kind. So you have a search for a proof, and then you have a language model that's going to suggest a bit of a proof. Um, and we already know that this works pretty well. um, I think there's a question of how much can you do, like if you don't even have the search procedure. um, and I think I was like yeah, I was surprised by kind of how capable these models can be. But I think this kind of self debugging loop that you're talking about is really the coolest thing. Um, we've been thinking for a while about how we could get uh, machine learning tools and language models to to repair proofs when they're a little bit broken. Um, and I think one of the questions that Emily and Marcus were especially interested in is like, can they repair their own mistakes? um, and I think that is it's a super cool line of work, and like it turns out the answer is yes. Like not always, right? It's not perfect, but like it does improve performance. It's really cool. Um, and so yeah, they were Emily was using error messages, um, kind of from the proof assistant when a proof didn't completely work. When a proof that the machine learning tool would suggest like did not completely work, and then use that error message to kind of feed back in and help it fix the proof. And this did improve like the overall proving power, which I think is cool. Um, I think also it's like um, so yeah, I think there's much more promise there than has been explored because these error messages are really uninformative. And so I think one of the really cool things about language models is just the flexibility of like the input that you could stick back in, like the additional information if you are interacting with a tool in some way. Um, so we could see it like there's probably more that you could learn from when these make mistakes to help it repair its own errors. So I think yeah, we like there's probably potential to do even better on that end. It was just really cool to see that work out. But lots of credit to Emily and Marcus.
Yeah, yeah, this was some really cool work. There are a couple of different things I'm wondering about here, but one of them perhaps that you could go into a bit of detail on. I thought one of the interesting research questions and takeaways was that in context learning is pretty effective for LLM based theorem proving. Could you maybe describe a little bit of what you found there?
Yeah, I think there was a fair amount of the tool kind of, from what I remember, like kind of copying and adapting similar proofs from like recent contexts, which is nice. And it is kind of similar in some way, I think, to what people will often do when you have a lot of kind of similar things in a single file. So like um, I don't know. I've looked at like there's this verified C compiler called CompCert, and there are these kind of lemmas that are in. There's just a file full of lemmas, and they're often like really similar with like really kind of small changes. Um, and you can see that. Yeah, sometimes I will literally copy and paste and then adapt. um, so I think it is neat to see this.
So, one of the things I wanted to ask about this paper too was your team, I guess, leveraged Minerva, which I know was pre trained on a mathematics corpus, if I recall correctly. And I'm curious if you or any of your collaborators have perhaps just explored capabilities for more recent LLMs like GPT-4 to do this without any fine tuning.
Yeah, that's interesting. So I think we're kind of currently playing with this. Both the UMass folks and some of my students are looking at some of the more recent models, including like GPT-4. I also know there's work from I don't know if there are any publications yet using GPT-4 for proof, which well besides the um, unless you count the Sparks of AGI paper, but I don't think that really that counts. But uh, yeah, but there's definitely other work in this like language model for proofs kind of space. Definitely some work with earlier like GPT based models. Um, and I think yeah, I don't know. It'd be really interesting if we can tease out the effect of like the kind of pre-training on mathematics. One thing that did surprise me was that I expected that because of the Minerva kind of fine tuning on mathematics and so on, I expected uh, that Baldur would do better on mathematics than other topics. But if you actually look at the topic breakdown of the proofs that it was successful at, it doesn't. And I don't know whether it would have done worse without that data or whether it's I don't know. There's some degree to which just seeing more information is just generally helpful. So yeah, I don't have a good sense right now of the effect of that.
Another kind of direction here I'm curious about too is I guess when sometimes we're writing proofs in mathematics class, we might be asked to employ a certain set of tactics or use a certain style of proof. Like you might be asked not to do a proof by contradiction, for example. And I'm curious if you're, any work that kind of is exploring sort of what you were doing with Baldur, but perhaps asking the model to construct proofs with various restrictions like that.
That's interesting. I don't know about like, yeah, not explicitly with restrictions. There is a lot of work from the past decade on kind of like, I already have a natural language proof that is using a particular strategy, and I want to translate that into a formal proof. I guess maybe not a lot, but like, I think it's one of the there's enough work there that's really interesting. And this does seem to be a place where the language models are extremely promising, and I think that's really cool. Uh, um, yeah, I think in terms of so yeah, I mean, you can find a lot of that stuff kind of cited in the Baldur work. We talk about a lot of these different kind of threads in the related work section. But um, as far as giving it a high level strategy, I don't think I've really tried that, but I think it would be interesting. Even try to pass in like natural language hints to the yeah, I don't know. There's so much like prompt engineering even that hasn't been tried or hasn't at least been evaluated. Um, where like if I know a proof should proceed by induction on some particular thing, right now the best way I know to pass to like the only way I've really passed this into some of these tools is by like I'll just write that first tactic and then it can continue. But like it'd be really interesting to see how it does with like you should prove this by inducting over this thing. I think depending on the training data, I could see it doing fairly well on that because if you look at a lot of like textbooks, they kind of like even textbooks for formal proof will kind of have these kinds of instructions to help people out. And I think also like comments that people leave in their proofs will often explain like this proof proceeds by induction over this thing.
One thing that I maybe there are probably intuitions on this based off of what we might see in training data, but one thing I'm kind of curious about too is the relative difficulty an LLM might have when you ask it to use different strategies for a proof that admits multiple constructions. And I guess I often think back to like various math classes. I remember like a very particular problem set, and I think like my second or third linear algebra class where I think I did like a series of proofs in this set by contradiction, and emailed my professor about it, and he was like, actually you should do these all straightforwardly and not by contradiction. And that made me want to cry because it seemed a lot more difficult that way. And so I'm kind of curious just how that would look for an LLM where maybe something seems a little bit more straightforward by one strategy. And I guess intuitively, like, you might see that reflected if it's more difficult for a human to prove something with X strategy over another, then maybe you'll see fewer proofs written that way. And so that might manifest similarly in the LLM. But I am kind of curious just about the interactivity there of maybe I'm trying to prove this in a more difficult way, and then kind of through interaction with the system, even if it's not doing it perfectly, perhaps there can be some kind of interactive guidance that makes it a little bit easier.
Yeah, that's interesting. Gosh, there are a few threads there. Yeah, I do think if you've seen if the in the training data there are a lot of proofs of one particular style, this will definitely help. um, I do think when you look at like proofs by contradiction, to me this is one example of a kind of proof where people have built really like easy abstractions that I expect a tool to be able to pick up on pretty well. Um, to like explain this kind of proof. And sometimes when you get to like if you're trying to show a proof without contradiction, um, you often have to show like really like why this thing is true. um, and at that point you're producing this like concrete evidence. Um, and uh, this is really like a kind of algorithm. Like you're giving an algorithm for like how to show that this thing holds. um, and so it does seem like it is a little bit of a harder problem. Um, even when you're operating from kind of no training data. um, insofar as it shows kind of like a more in humans, I don't like ascribing understanding to tools, but in people it would show more of an understanding um, of what you're actually trying to prove to some degree. um, and it's more informative in that it's actually something that you can reuse when you have a proof that when you have a proof that's by contradiction, a proof that like not X or something, and you show that that shows X. um, uh, like this, if you change X really slightly, um, and now you're trying to prove not Y for some really similar thing, um, it's there's no guarantee at all that the proof of not X is going to help you with that. There's like deep mathematical reasons for this. But if you're proving X by giving an algorithm to show it, without ever doing this kind of contradiction thing, and then you change it a little bit, um, this actually is often extremely useful information to help you change the proof. Um, so I don't know. It's like if we had a lot of that information, then I think it would be universally easier. um, I I don't know. It's a hard question. Yeah, in terms of interactivity, I think this is a place where we could explore the Baldur like kind of thing even more. Like it's not just that it can kind of correct its own mistakes, but like if you can kind of explain a mistake to the proof, like yeah, to the tool, it'd be really interesting to see how much it can learn from like your explanations of its mistakes as well. Um, I have a lot of hopes for interactive tooling. I know some people diverge on this and want to see a lot more like complete automation, but to me, I think like I don't ever want to take the human completely out of the loop. I just want to make it very easy for the human.
Yeah, I do think that makes a lot of sense, especially in the context of, I mean, programs are still things used by humans, and I think like making sure the human at least has some point of understanding of like what's going on, something a little bit deeper than just like I gave you this program, you told me it works, cool. There's a proof out there. I don't know anything about the proof, but it says it works. That seems kind of dissatisfying.
Yeah, I mean it's also scary. Like what, I don't know what exactly is proven about it,
Yeah.
and what is not proven about it is always an important question.
Well, speaking of scary things, maybe we can turn the arrow back a little bit and talk more about how proof engineering, how proofs can help us better understand things about ML systems. You mentioned kind of your interest in guarantees on LLMs for code, but maybe we can start even a little bit simpler than that and talk about just a bit about the idea of a verified ML system, because I think that's kind of feels a little bit weird, right? We have this idea of like robustness in deep learning systems. Of course, that being like I perturb my inputs a little bit and hopefully that shouldn't produce a massive difference in my output. But really being able to provide formal guarantees seems at the very least difficult, if not impossible. So I'm curious if you could maybe just start by describing a little bit of how people think about this.
Yeah. So this is interesting. There are a bunch of different kind of tools and techniques to begin with for any kind of verification of machine learning systems. Um, so I think there's a really good textbook by a professor at like Wisconsin, neural network verification. Yeah, it's a good book and it kind of shows like what kinds of different formal guarantees you can get and how you can show them. Now, I do think this is a different kind of set of tools for verification than the ones that I typically use, um, because the ones that I typically use would have to peek into the internals of a system to some degree. And this is something that's still so hard for us with these systems. Like, we just don't uh, have a lot of ways of doing that right now. Um, but I am really interested in seeing whether that is possible in the long run. And we might have to start with like really simple neural networks, But there's a way in which you could have, if you had an interactive tool that let you both peek into the internal details and interactively reason about them in like this sounds like it would be really useful even as like a way of exploration, um, and like interpretability. So I am interested in it, but I don't know how practical it will be in the long run for that particular style of verification for really large networks. But I hope people will explore it for the more kind of, yeah, for the more automated verification. It's I think already quite useful, which is really nice. Um, so yeah, for the kinds of things where it doesn't need to peek into all the internal details. Um, Yeah, for this more interactive verification, there's the trained model, but there's also like the the algorithm that you're implementing when you actually train it. And this is another thing where you can have guarantees about it, and I think that's also useful, even though they're not guarantees about the downstream system, because there are so many ways where you mess up when you're implementing some of these systems, where it's not clear what on earth went wrong because everything is so tightly coupled. So I've also seen some promising work in that direction.
Let's maybe start with the idea of just verifying kind of the input output behavior of these systems, and maybe we can work our way to some of the internal questions, because I think that's definitely of great interest to certain groups of people within the AI community. But even just starting at, I can kind of verify that for a certain set of outputs this neural network satisfies certain behavioral constraints or properties. Could you maybe go into a little bit more detail about what that looks like, kind of how people are thinking about it? You mentioned your interest, of course, in guarantees on LLMs for code, which you kind of want to work towards. So I think also maybe in today's kind of current climate of like LLMs everywhere, perhaps how we should be thinking about some of these things.
Yeah. So I think currently, um, what a lot of people are doing, um, so let's see, if you're looking at just the input output behavior, you need some kind of statement of like what the data that you're going to be looking at is, like what actually counts as like out of distribution data for, if you're looking at like robustness guarantees, which I think a lot of these things have been kind of formally stated in English and like in or in natural language proof style, in a lot of the machine learning literature. So it's not completely unreasonable to do so. And then you also need some sense of, um, oh yeah, so you need the inputs out, like input outputs, like the data, and then I think also a lot of these guarantees are not like they're probabilistic in some sense. For a lot of kinds of guarantees that you'll get about machine learning on a lot of tasks. The reason that we use machine learning for these tasks often is because there isn't like a complete solution that we could write and state, and so um, and so then you often will have kind of probabilistic guarantees. Um, and there are ways to reason about this. It just means that the guarantee kind of will encode that. But I think there's a more granular, interesting questions, which is like when you do have something that falls into that like low probability failure case, like what is it, and do you want to rule out like specific kinds of things that could fail there? um, and I don't know how much that's been explored at this point, but I think it's a really important question, because unless you take a really like pure utilitarian view of the world, even if you do take a utilitarian view of the world, I think like there are ways in which if a machine is much more reliable in terms of probability than a human, I would still want the human to be doing the task if I didn't know in which ways the machine was going to fail. um, like if I think about like disproportionate impacts for different kinds of populations, this is something where this would bother me a lot if we released a tool that was, more effective than people, but like disproportionately impacted like a group of people more than others in a way that I would not find acceptable. So um, yeah, and then I don't know. There are a lot of interesting questions there. I think a lot of them are also very hard, and I think we also have to be very wary of like technological solutionism as soon as we start talking about the things that have people involved in them, like yeah. Um, yeah, and then so on the code side, I think there's an extra promising thing where so you can fully verify some systems ahead of time, but there's this difference between like a certified or verified system and a certifying or like verifying system. And the latter is actually what I think might be really cool here. It basically means instead of proving that this language model always gives me something good, um, when the model spits something out, I have it also spit out a proof. Uh, and this is really cool because if you look at like we're making so many strides in like this proof synthesis world. We're getting these models to prove things. We're also using these models to produce code. It seems pretty natural that we could have them spit out code and at the same time a proof about the code. um, I find that super exciting. And yeah, it still brings up again, I think like the HCI questions are just completely unavoidable always. Like it's still, you have to be careful, like what is it proving, and how do you actually help the human understand what it's proving and make sense of it and make sure that it matches their kind of expectations and fix it if it's wrong, and not fall for, there are just a lot of cognitive biases that can make you trust the automation too much. Um, so those things will still come into play, but I think it's really that's where I'm most excited because it's just such a concrete, like useful case where I don't have to reason about the entire neural network behavior. I can use this kind of like task where these tools are already like getting pretty good, and just really concretely like help just expand the like guarantees of these tools that people are already using in real life. So yeah, I'm very excited about that. I worry a lot about these tools producing incorrect code and people just believing it. And yeah.
That's a very important concern. I I think maybe as a transition towards discussing more about verifying and thinking about internals, there does seem to be this, I don't know if it's really a debate, but people certainly have different opinions about how much we should care about the internals of what is going on in these ML systems. And I think in a lot of ways, I mean, this is not a categorical thing. It seems circumstance dependent. You hear certain people in the medical community, for instance, say things like, if this deep learning algorithm is not super interpretable, but I am guaranteed that it will provide good patient outcomes, then how much do I really care about what is going on inside? But at the same time, with the emergence, I think, of systems that are trained with reinforcement learning from human feedback, people like, I think Ian Hogarth kind of pointed this out in his recent article, that the whole like Shoggoth meme, with like the little smiley face on the front, does represent a very real worry about this thing that is maybe just pretending to be aligned with human values when in reality you have no idea what's going on. And that's like, if you know that the smiley face is going to be there everywhere all the time in every situation, maybe you don't care. But it seems a little bit concerning that maybe we don't know that. And I'm kind of curious how you look at all of this.
Yeah. This is interesting. Yeah, so I guess the reinforcement learning with human feedback thing is interesting because I think it's very much like it learns to like tell you what you want to hear.
Exactly.
Recently, Google's Bard, which I sometimes use for some things, like I like it, but I was asking it about like I play Pokemon, and I was like, "Is it weird to be emotionally attached to like my Jolteon?" And it was like, "No, that is perfectly normal. Like enjoy all the time that you spend with your Jolteon and make the most of
Oh,
it." I'm like, "Wow, I feel emotionally affirmed, and also this is bad advice." Like,
right.
um, Yeah. So, but anyways, I think, yeah, that God, there's so many questions in there. Like, so I think the internals matter a lot. But I think they matter for, so I'm not worried about, evil AI taking over the world or anything like this. To me, this is kind of a science fiction like thing. But I do think a lot of the work that people are doing because of that is amazing, which is really a strange place to occupy. So like this mechanistic interpretability work where people are really peering in and seeing how these networks like function is awesome. And I think it's awesome for a slightly different reason, which is that I think if we just look at input output examples, we are very likely to miss really important cases or to kind of test on things that don't correspond sometimes to real life outcomes, or, even to like, I don't know, just to, I think there are just so many ways that this can go wrong. Yeah, another way is like these are just, um, in a lot of like programming languages work, even in software engineering, like when you look at program repair tools, there was this big fallout a few years ago where a bunch of these tools were just checking things on tests, and it turns out that the tools were just really good at gaming tests that were really underspecified and didn't handle all these scenarios, and you'd have tools introducing bugs into your code, and then it would be like everything's good. It's passing the test. That's horrifying. And it does kind of represent that meme in some way, except that I think it's just wrong to kind of. It's not. I'm not worried about evil. I'm worried about like bad like, things just not working. I also think when people look at something that passes a bunch of tests, input output examples, whatever, um, there's a tendency to kind of think about how you would solve a problem and generalize in that way to how you think it's solving it. So, like, you see it doing really well, and you're like, oh, okay, well, it should be able to handle these cases because I would be able to make this inference. And then it's not what happens. Like, you see kind of the adversarial examples that pop up, and they're so weird. They're things that would often never confuse us, like like the iPod on the Apple kind of thing, right? Um, so I think one of the really promising things about this kind of mechanistic interpretability work is that you can go in and you can look and try to find out like what algorithm is being implemented to learn this thing. Um, and maybe this becomes really hard when you're looking at fancier and fancier things where there are kind of clear guarantees, larger models, everything. But like I think there are a lot of cases where this is extremely, extremely promising and where it tells you really important information. Like, if I can tell that it's implementing, like we've been looking at these recursive functions, if I could tell that it's really learned the recursion, then I know that it's going to fully generalize, like to anything I could think of, and that's amazing. But like, if I can see it cheating, um, in ways that work on these inputs, like I could also see it failing in ways that I hadn't anticipated. Um, and yeah, so I think there's this emphasis. Yeah, I don't know. I think how it learns is really important, and we do want to know this because it tells us more about the cases we can't anticipate.
Yeah. And I guess practically, it really importantly, I think, manifests in, well, I know that the system has picked up on this algorithm. That gives me some information on the context in which I might be comfortable deploying it. And I think you kind of gestured at this worry earlier that you're more worried about bad than evil. And I think a good number of people, Jan Leike, for instance, have kind of brought up the worry about if we have LLMs all the time, everywhere, and all these critical systems, this worry about correlated failures, which does seem like the right kind of worry to have at this moment. I am curious from your perspective, just when it comes to alleviating those kinds of worries and ensuring the safety of the system, it seems kind of as you said, difficult to be really sure about the internals, especially for the powerful systems we might want to deploy. What would be, I guess, I suppose, like what level of verification would give you perhaps more comfort that maybe we're okay deploying these systems in certain contexts?
Yeah, I think this is going to depend a lot on the context.
Yeah, of course, of course.
Yeah. I will say, um, I think it's really important just not to forget about the HCI problem. And I think there's a lot of people will focus on what can we verify, what can we interpret, and there's this additional question of like people are using these tools. How are people going to interpret their outputs, and how is that going to influence their behavior? Are people calibrated to not trust these things? Enough, or are people just going to believe whatever it gives them? Um, so I do think in the shorter run, like I just want to like I wish that there were regulations that mandated that if you're going to release a model that you aren't able to interpret or verify right now, and have it interact with people, that you had to first study like how people interact with it. Like I really wish that we had that. To me, what seems the most irresponsible right now is that people will just release these tools without taking the time to do that kind of user study. Um, so to me, that's the most urgent question is like this human like language model interaction, which is funny because it's not my area, mostly because I don't have the patience to fill out like IRB forms. but but if I were in charge of the funding, I think roughly half of computer science funding would just go to HCI, and this would be a central question. Um, but yeah, I think then once you have that, like a little further out, because I think we're just earlier in our understanding of how to do this. Then you can have peeking at understanding the internals, um, and verifying that the systems behave a certain way. And I think as soon as there's a possibility of like real harm from these systems, or as soon as someone's trying to take humans out of the loop in certain parts of these systems, then I'm going to want much stronger guarantees and a much stronger understanding of what's happening, um, relative to like I don't know, like one use that I use Bard mostly, and I think the main reason I use Bard and not ChatGPT is because of this like security breach recently, where I don't want to give ChatGPT any of my personal information. But the sometimes like I have ADHD, and like I have trouble reading like sometimes I get these long emails where they'll mix actionable information with unactionable information, and I can't understand what I'm supposed to do. Um, and so I will kind of paste them in, like read out any sensitive information, and then uh, and then ask Bard or whatever to like give me action items. um, and and in that case, I don't really care that much how perfect it is. It's much better than I would ever do, because the alternative is me freaking out and closing the email, uh, or like forwarding it to my mom and asking the same question. like, um, and and I can kind of check it when I get the output and see like, oh, okay, are there obvious action items missing here? Um, and in that case it just doesn't seem as important to me. But when I'm looking at producing code, I do think it matters a lot, because this code gets executed, and it can get executed in like arbitrary programs and you can't just tell people, oh, like don't use this for important things. Like they will, for sure they will. um, and So any time it involves executing code, I care a lot, I think, about it being correct, or about people being able to catch when it's wrong. Um, and yeah, and then when you have critical systems, of course, like I think I'm horrified by the standards for like if I look at like Tesla's like self-driving cars and stuff, and like how you can just the fact that you can release those systems, um, without much more stringent understanding of when they're going to go wrong, and just beta test them on real life people who can die is like completely horrifying to me. Um, and yeah, I think that's kind of one case where just we should be able to understand what's going on inside, and we should be able to prove things about them.
Sure. And even besides failure modes, I think active malicious attempts to do things with these models, to perform prompt injection attacks, to do, I don't know, maybe ask them to do somewhat nefarious things. I think people have expressed worries recently about, if you want to conduct phishing attacks or hack into systems, now maybe the kind of dual use nature of these systems allows you to do that while being a little bit less technical than you would otherwise have to be. And so I guess that's in part a big question of maybe verification, not in the sense of robustness necessarily. Like, I don't know, if I ask a system to like do something really dangerous, maybe the question there I'm concerned with is not that it does that dangerous thing correctly, but that it doesn't do the dangerous thing. And so that seems like a related, different, but also very important question along the same lines.
Yeah, that's true. Yeah, it's interesting because right now there's kind of like a whack-a-mole approach to this, is what I've heard people refer to it as. Um, and it's like, um, yeah, they're just, it's so easy for it to go wrong. I don't know. I think like dual use is just inherently hard. I do think there are situations where like I don't know, I was playing with Bard the other day, and I was really curious like what it would be like to pretend that Bard is a barista and try to have a conversation where I order a coffee. This is mostly prompted by like my students were talking about there used to be this like robot coffee place near UIUC. It's a really simple robot. There's actually like no machine learning going on in there. It was just like it would serve the coffee. Everyone thought it was really cool and novel. So I was like, what if we had a language model in front of that? What would happen? Um, and so we had a really convincing conversation. And then at the end of it, Bard did exactly what it should have done in that context if it were really a barista, which is ask me for my credit card number. Now, of course, in a system that is playing improv with you, where my upvotes and downvotes are going to go into what it does in the future, and I could be any user. Like, I don't want it asking for my credit card number because what if my mom might put her credit card number in response to that prompt or something, and then that's scary. And I don't want that in any of the logs. And yeah, so it's like sometimes I don't even know what the right behavior is. Like I downvoted that response and then explained it, but like um it was doing the right thing, but maybe it shouldn't have been doing the right thing there. Um so I don't know. And that's kind of a more innocent one. Yeah, I um you're also things like you can write code that's like calculate someone's salary and then be like, oh, okay, now edit it to add like gender as an input. And like I think the obvious thing that like I would like a model to do in that case is be like, no, like you shouldn't be calculating salary based on gender. Why are you doing this? um, but instead it will just kind of entertain you often, unless sometimes it entertains you in some ways, but then if you phrase it slightly differently it doesn't. um, so yeah, I don't know, there's this whack-a-mole approach right now that's clearly not sustainable. um, but then I don't know in the long run exactly what we'll be able to fix about that. And um, I think it's clear we need something that isn't whack-a-mole, and it's not clear exactly what that thing is.
Yeah, some of the concerns you raised really speak to like the innocent example you gave. The asking for credit card info is kind of right in one context and wrong in another. But unless you're able to be really, really secure about what information your LLM will and will not regard as true, I mean, you can just tell the LLM that it's in a different context and lie to it. And then it'll start to do what you want. And I think we've already seen this. And a lot of the prompting people have done to get around various restrictions that ChatGPT et al. Have.
Yeah. Yeah, and I think and sometimes I like it, like which is also an interesting thing, but like you know, 'cause sometimes it's such a weird world we're in, but like people will use you know, ChatGPT to like look up information about people, even though it says that you like shouldn't be doing this. People just do this anyways, basically. And then often it's wrong. Or one of the online ones like Bing, like their bot, the chat bot, people will ask for information about people. Often it is like incorrect in annoying ways, and I just don't want someone doing that to me. Like I'd rather someone just look at my webpage and use that as like a source of truth and not ask a chatbot about me. Um, and then on the other hand, so I've seen these cool attacks where people will add like, some invisible text to their website that will then change how, Bing behaves when, it searches for information about them. And I'm like, I actually really like this. Like, to me, this is a good use of jailbreaking because I don't think this is something that the model should be used for. And I want to be able to, like, what I would do is add some text. I haven't done this yet. I want to add some text to my website explaining the limitations of these tools and why it doesn't make sense to use them to look up information about people, and how they can go wrong, and just I would just have it like amend that to the output in some way. And,
I like that.
um, yeah, so it's just a hard question of how these should even be behaving. Like sometimes the way that people use these tools is not what I want to begin with, and the jailbreaking actually kind of can fix that in some way.
Sure. Going up a level of abstraction, I do really want to ask you about, you kind of mentioned that you're not so worried about evil AI and that you kind of view it as a science fiction thing. And just for the sake of elaborating on it a bit, because I think that often when I hear people have this debate, I mean, some people give reasons for it, but often it just feels like I'm not too worried about this. And I think often people seem to talk past each other and maybe aren't super satisfying with the way they articulate themselves. So maybe just for kind of, giving an example of this, would you mind elaborating a little bit on why you personally aren't so concerned about some of these things?
Yeah. So this is an interesting question. It's definitely a can of worms, but I think a lot a lot of these worries about kind of evil AI seem very like apocalyptic in nature. And they're based on really long term, like theoretical ideas of what could maybe go wrong, often with some really strange assumptions, and talking about sort of these runaway, like self optimizing situations, that just seem like, to me, it's one of those things where like the burden of proof, like, extraordinary claims require extraordinary evidence. And to me, these seem like extraordinary claims. Um, and then on the other hand, I think a lot of times when these extraordinary claims are presented as ordinary, this kind of inflates the capabilities of current systems, and in a way that I actually think is more harmful. um, like I think it starts to like anthropomorphize the systems more. It starts to kind of make it seem like we are further along than we actually are, in a way that could make people trust the outputs of these systems more. And then like actually cause much more damage, like having bugs in produced code that will then like be introduced into some critical context, and then someone dies because of that. And it's like, and to me this freaks me out to the point where it's like we really like need to have conversations that are very grounded in like where we currently are, um, even when we're talking about what the future might look like. um, and if we don't do that, then it's just so easy to cause more harm than there, than good. Um, so I think that worries me a lot. And then I think, yeah, there's just some disagreement with that community. It's very utilitarian and very like long term focused in a way that I just don't think is healthy. I think it's a kind of reductionist view of ethics to like this kind of one dimensional equation. Like, it just doesn't seem healthy, and you're dealing with, yeah, I don't know, I think there's so much that can go wrong there. And it's just easy to conclude really extraordinary and kind of messed up things, and like what you should do in preventing this theoretical outcome. um, so yeah, and it's hard because there is a lot of common ground in terms of like techniques that these people are interested in. Like some people I talk to in verification are like, oh, I actually got into this like from people on Less Wrong. And I'm like, whoa, weird. um, and like, yeah, and then I think the mechanistic interpretability stuff like really came like from that community to a large degree, and that work I really love. And the reason that that work is being pursued, I really dislike, and I don't like the rhetoric around it. And how do I tread this line in a way that's like respectful to people but stays true to the message that I think should be conveyed about these systems and how we should act on them, and doesn't cause harm is a really hard line that I definitely do not always tread correctly.
There are a few important things in there. Yeah, it does seem like you do have to buy into a few different assumptions or be really careful about believing a few things to be true to really get on board with it. I know one very important one, for example, is the orthogonality thesis. And of course, Eliezer Yudkowsky will kind of say that the whole paperclip maximizer thing is sort of like, you know, a an inaccurate caricature of what he was really talking about. But I guess to like believe in that as a thing, I think like Scott Aronson has kind of pointed out, you have to believe in this really hard version of the orthogonality thesis where your intelligence and your goals are completely independent of one another. And I know to him, it seems kind of implausible that those two things are entirely distinct. I think the way that he argues for the converse of that statement, I'm not entirely sure about his example there, but I do think that it seems reasonable that like your level of intelligence and the goals you're going to have, it seems that the idea of them being completely distinct from one another, that does feel a little bit implausible, at least intuitively.
Yeah, I get weird with this because I really I think that actually talking about intelligence when we talk about these systems is actually just another example of harm. And it's hard because we've really like every time funding pops into this area, it stops being machine learning, whatever we are currently doing, and it becomes artificial intelligence. Like, but I do think like it first of all, it causes us to personify these systems, make assumptions about how they're actually behaving. Second of all, I think especially when you start talking about like so-called general intelligence, there's like a deep like kind of eugenicist and like racist history behind like even the assumptions of what that means. And when we are talking honestly about both people and tools, I think we should be talking about specific capabilities. And that specific capability might include some notion of if they're given a new task that's new in this particular way, it should be able to pick up on that task. But I just don't think that. I just wish that we could just completely abandon, at the very least, the use of the like general intelligence thing, um, which is really deliberate in picking and choosing like what kinds of tasks are even considered in it, and also makes this false assumption of like uh, that there's this one factor behind everything, whereas people are like it just I don't know, diversity is just good for a lot of these things, actually, both in people and in models we've seen. So like we want that, we want people who think differently, we want, even if we are going to you know um, but like anthropomorphize a little bit. We think we want models that are able to specialize and interact. We have a mixture of experts model for GPT-4. Why are we talking about this like general thing in that case? Yeah, so I don't know. This takes me down a major rabbit hole, but I wish we could just abandon that to some degree and just talk about what our really specific worries are and how we're going to mitigate the harms of those things.
The discourse does seem to have gone off the rails these days. I think we're, seeing things that kind of cause everybody to go crazy every couple of days now. You have projects named AutoGPT that kind of imply that recursive self improvement. You have projects named Baby AGI that, of course, are not doing the best, I think, when it comes to naming. And it does feel a little bit worrying. And at the same time, when it comes to grounding our discussion in what the real and current capabilities of systems are, it does feel at times, I mean, especially when you have things like GPT-4 where the nature of the system, training data, things like that are not disclosed, it becomes even more difficult to have those grounded conversations because I think that we become, well, not become, but we are not super clear on what the capabilities of these systems are. And then figuring that out becomes a pretty onerous task. I think with GPT-4, you had the whole debate over professional benchmarks as a mechanism for testing the capabilities of these systems. Arvind Narayanan had that wonderful Substack essay where he kind of pointed to these are the wrong answer to the wrong question, not a great way of testing how these things really work, and examining some of the data contamination and things like that. But it does seem like it's just becoming even more difficult to have like a stable conversation about what these things can actually do and what they do actually do.
Yeah. Yeah, I think one of the most important like regulatory pushes is for transparency. um, but even with transparency, it becomes hard. Like you have if you have that much data, um, to even how do you even know? Even if you're trying to sort through all that training data, knowing what all of it is still hard because it's just incomprehensibly large. Um, and then there's the behaviors that kind of come out of this, and I just think we need to make sure that we don't make assumptions based on how people do things because it's just fundamentally so different. Um, and so, yeah, I think that's the starting point. It's just a normal effect, though, to some degree. I think when we have a technological revolution, people will always freak out in both in many directions, and it's just to some degree that part seems normal to me. And I think we should also just look back at history, at like these previous technological revolutions. And I don't think what we're doing is really that special compared to all the other ones. And there were negative effects. And I think that it's important to learn from those. Like there will be jobs that are automated away, often for lower quality automation. And we should be like mitigating the economic harms of these things now. um, but I think we lose our ability to do that when we start to imagine that we're in this special place that has never happened before.
Yeah, I think I definitely have sympathies with that viewpoint. At the same time, I mean, I do have friends who are like very smart people who are like, well, a lot of researchers that I respect are pretty worried about these things. And I guess you have the whole like 6 month moratorium letter, and people maybe disagree with each other about some things, but sign because they agree on other things. And you hear very big voices like Ezra Klein, who are like, I don't know what the world is going to look like in a couple of years from now. And to what you said about this technological revolution being very similar to others, I think in the way it's manifesting, that seems right. But at the same time, I think maybe what gets to a lot of people is that at least the aspirations of the research field. And you did point to how problematic it might be to talk about like intelligence as kind of, the notion of this thing. But that does seem to be like what people are after. And I remember in his whole here are my thoughts on AI thing, Ezra Klein kind of pointed to, I forget the name of the book, but there was this particular quotation. I think I brought this up to somebody who I interviewed previously as well, just that the way we used to distinguish ourselves from non human animals was by means of higher cognition. And then now that we have these AI systems that are capable of doing quote unquote cognitive work, whatever in the world that is supposed to mean, we're like, okay, now I need to think about the ineffability of what it means to be human and how it's kind of a reversal of that logic, which I find to be a reductive way of capturing what's going on in all sorts of ways. But I guess it does seem like we have a lot of like very high profile people who are saying lots of things like this and that are like affecting the mainstream discourse in lots of important ways right now.
I think if you tell a bunch of really like uh, people who are really smart by like common definitions of smart that being smart is the most important thing about being human, and that we're making things that are that are going to do this, and then that's a natural outcome. um, but I just don't like I don't think it's real. I really think um, that intelligence is like it's socially defined based on what is currently hard for people to do, and also aligned along like axes of power. So if I think about the most impressive so-called cognitive task, which people, I don't even know what this means. What makes a task cognitive versus not cognitive? Like judo is cognitive to me, but that's a martial art, and we're not. No one talks about AGI in terms of like how good the judo bots are. Um, and yeah, I don't know. I think about like uh, um, the most impressive thing I feel like I've done is I started an international mentoring program where there are like 500-ish people participating across 42 countries, and I'm able to manage them, and now I'm not the chair anymore, but like for 2 years I was able to manage them, and I still give coaching advice to all the mentors about all these individual relationships. It's this like emotional thing, and I think it's actually like a sexist history behind why this is not valued as like a kind of intelligence. um, and when people talk about what these tools can do, this is never a thing that they're caring about. But people talk all the time about proofs, which I find hilarious because it's like I can do that too. Like I can write proofs about proofs. I can write proofs about how proofs relate to each other, and I just don't think this is the most like impressive thing that I do. Um, and I don't feel threatened by tools that are going to make that easier. Um, yeah, I also think people have just an infinite capacity to think of new important tasks. And so, like, whatever it is we value ourselves for at the time, I think there's always some adjusting um, when we make it easier, when we build tools. Um, and we should make sure to mitigate the harms of that adjustment period. But then there's a period where we find new things to value, and that I just don't see that stopping. So, yeah.
The finding new things to value part seems to be a very important facet of this that I think a lot of people are thinking about. But the articulation that you just gave, I think, might be one of my favorite. That, the idea of smartness as being socially constructed, grounding in context and time, and that not being what's most core to being human. Um, I just really like that articulation of it. I think that's an important way to think about this. I think this is maybe a good place to close out, and perhaps where we can end here. I think this is kind of already a good note, but maybe as a final few questions. First, we kind of discussed a few of them, but you do have a lot of interesting research ideas that seem really exciting for this kind of intersection of ML and proof systems kind of going in both directions. And to wrap that discussion up, I guess I'd just love to hear about what directions right now that you're most excited by.
Yeah, interesting. I really think anything I can do to bring verification to people is what excites me. Like the idea that we can make these things that really take a lot of expertise right now, something that like other people can do, and that just excites me. So I think really the kinds of like interactive tooling for producing guarantees about either code that you wrote or even code that a tool is writing for you, and helping you understand those for sure is like one of the biggest ones. I do also really get into how to improve the actual tools and architectures, which it's really funny to me to go from this place of like I don't care about machine learning to like I want to improve over the transformer architecture so that it can properly represent recursion. And I think the best step to do this is to first understand what it's doing right now. Like, but I do actually like really really care about that, and I'm excited as well, to see what we can do there.
Awesome. I think that's a really great place to close out then. Well, this has been a really thoughtful, interesting conversation, and I really appreciate your time, Professor Ringer. I think that you have a lot of really interesting directions that your work is going in, and I appreciated your thoughts on some of this tinfoil hat stuff as well that we're all thinking about right now. So thank you.
Awesome. Thank you so much.
And that is a wrap, my friends. As I mentioned at the start of the episode, you can subscribe to The Gradient on Substack to receive not just this podcast, but also our articles and newsletters directly to your email. You can also visit us at thegradient.pub, where you'll find all of that, as well as more information about The Gradient and how you could even contribute if you're interested. And finally, if you enjoyed this episode, we would really appreciate your feedback. If you'd like to leave a comment or review, we'd love to know how we can make this series more interesting and informative to you. And with all that, I'll leave you until the next episode.